This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
Once again, the sealing capabilities of hydraulics, the motors and pumps, you can put them in a real caustic, dirty environment and they live.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us on Twitter at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. We're happy you found us. You can find us on Apple Podcasts, on Spotify, on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. Those ratings really do help promote the show and help more and more of our friends in the industry join in on these important conversations. On today's show, our guest is Dave Heiling. Dave is a technology manager at Nott Company. And Nott is a supplier of fluid power products and systems, of industrial products and custom rubber fabrication, including software and controls options that all enhance the performance and control of fluid power systems. And Dave recently gave a presentation on one of NFPA's quarterly conferences on lowering emissions in turf care applications through a hydroelectric hydraulic system. And so we invited Dave into our forum to learn more about that application and the fluid power system that makes it possible. So Dave, welcome to Fluid Power Forum.
Thank you, Eric. It's good to talk to you again.
We're glad to have you on the show. I really enjoyed the presentation you gave on that conference a few weeks ago. We're happy to learn more about it and spread the word a little bit more in our podcast forum here. Tell our listeners a little bit more about yourself and your background. How did you find your way to Nott Company?
Oh, okay. It's been a long path, but
take your time.
It's a real short introduction. I grew up as a farm boy in southwestern Minnesota. After high school, my dad said, there's no future here in farming because there's 11 kids in my family. So wow. I was right in the middle, and he goes, you need to go find something. I really was really interested in all the mechanical parts. Actually, we had some tractors that had fluid power, hydraulics on them. But right. my knowledge of that was, basically hooking up some cylinders and watching the disc and diggers go up and down.
Right.
So anyway, I went to fluid power school at Granite Falls ABTI then after high school.
Right.
It gave me a real good background. It sort of, enhanced it with everything that I, learned on the farm. And I just became real interested in continuing with that. Mm-hmm. John Favre hired me, right out of Granite Falls. And I worked for him, in their Eden Prairie division. There was the mobile hydraulics division. And I did some warehousing at first. They moved me into inside sales, and then later went to engineering. I designed some, a lot of fluid power circuits and manifolds. And as that time went on there, I just saw that there was more and more integration of electronics into hydraulics. So at that point, I go, I was so interested at that point, I decided to start taking some night classes. And eventually I got my associate degree at Normandale Community College. And then I transferred to the University of Minnesota, where eventually ended up getting my double E. So after that, I was working for Favre. Favre then got gobbled up, just like a lot of these other smaller companies in fluid power, but they got gobbled up by sun, a sun source now at that point.
Right.
And so I was going to look for another job, but then at that point, my boss at the time, Ron Sandy, said, why don't you come back? And, we really are trying to get more involved with electronics, and I'd love to have you be my engineering manager. So so that's what I did. Started working for them, continuing on my hydraulic plus electronic knowledge. And it's been a long path. In 2002, I had the opportunity to leave SunSource, which it was a hard thing to do. Sure. You've been there that long. Yeah. But the Van Hecke brothers started their own company called Vantech, and so they offered me a real good opportunity to continue that same electro-hydraulic integration with their company, because they had just so the Van Hecke brothers just got a new arrangement with Parker in their mobile division, and Parker offered it was a mobile technical center, and they offered the Van Hecke brothers, Vantech, an opportunity to pursue custom integrated circuits, hydraulic and electronic, with all of their mobile products. So I thought that was a great opportunity. Yeah. So we built the Vantech company up and to be a systems integrator by applying those fluid power products. We provided a lot of pretty nice systems. At the end of my time at Vantech, which Vantech got purchased by Nott Company in 2020. Okay. But at the end of my time at Vantech, we started getting into these engine off systems, which were small power units that were battery powered, but yet they had hydraulics in to do this a lot of these man lift applications for engine off applications for overhead power lines. Yeah. At that time, I didn't know if I was going to stay on with Nott Company. But Marcus Rushhouse, who's our CEO, said, "Hey, we're going to continue this venture into applying electronics with the hydraulics. So you want to stay on, and you can be my R&D new technology manager." So anyway, wow. There I am today. I'm still working in the field and still trying to apply hydraulics and electronics onto mobile equipment.
Yeah, what a great opportunity. I mean, Marcus is no. He's a pretty sharp guy, as we both know, and he's obviously seeing the technology trend that's happening, that's almost taking over the fluid power industry right now. And sounds like he's using you to stay on the cutting edge, if you will, of that electrification activity.
Yeah, it's a good. I didn't really want to leave and go elsewhere, so it's a good fit, and I'm glad that they found a good spot for me, and I'm leading a bunch of younger guys that are all willing and able to get into these new projects and start applying the engineering process.
And that backstory that you gave us was also revealing. It sounds like, I mean, you have a very practical through line. It sounds like you've been very hands-on for a long time, even going back to your first experience at Granite Falls. It sounded like.
Absolutely, yeah. It's a good base. And matter of fact, I think I still push a lot of kids to that are coming out of high school, don't know what they want to do. I still push a lot of them to go to the tech schools. Yeah. Even though a lot of the guidance counselors now in high schools are telling them to go to a 4-year college, I think that even if they go to a 4-year college afterwards, I think they still need to get that technical background that fluid power offers.
Yes, absolutely. I mean, I would agree. To this day, I think the technical colleges is where you'll get more of the hands-on application of the fluid power than you will at the 4-year degree schools. But maybe that's a discussion for another time. So
yeah.
But that's a great backstory. Appreciate you sharing all that. Tell us a little bit more then about Nott as a company. I don't know that everybody is as familiar with them as maybe they should be. What do they do? How big are they? Where are they located?
Okay, Nott was founded in Minnesota in 1879. They got their start providing, leather belting to industrial milling and lumbering, applications and plants, and that was the main industry around here back then. Okay. I think Nott's sort of a chameleon, because you don't stay in business this long without being able to change with the times. Today, Nott has there's 4 divisions. There's a mobile fluid power division, of which that's who I work for. Yep. industrial fluid power division. There's an engineered material division that does all kinds of neat stuff with rubber, foam rubber, insulation materials, you name it.
Right.
They've got those that they deal with. And then they also have an industrial engineered solutions division as well. There's 8 locations, or we're all in the, the upper Midwest. I won't go through all of them, but we're really within, Minnesota, Iowa, Wisconsin, and a little bit of Michigan.
Yeah.
So,
and I know we're going to talk about an application for the turf care market. Is what I'm assuming you guys work with a lot of different markets. Where are your primary focus areas, market-wise?
We still do a lot with ag, road construction, material handling divisions. We deal with a lot of people that build loaders, things like that. The refuse industry, there's a lot of refuse manufacturing in this upper Midwest. We deal with that. And then we also deal, obviously, small turf care applications. Toro is a huge company in Minnesota. And there's a lot of other turf care customers around, OEMs around this upper Midwest as well.
Well, so you sound like you're pretty diversified in terms of where your products and services are going. That really speaks to how ubiquitous fluid power is, right? You find it in so many different places.
Exactly. Yeah. There's a niche for it everywhere.
Yeah. So let's get into the application and the content of the presentation that you gave again a few weeks ago. And as I said, it's a turf care application that the hydraulic solution is designed for. Maybe we should start with a little bit of information about the market and kind of what are some of the trends that you're seeing. I mean, it's a hydro-electric hybrid, hydraulic hybrid unit, right? So why is that something that is appealing in the turf care market? What kind of trends are you seeing there?
Well, this particular case started, one of our customers builds turf care equipment, right? So these actually 2 machines that we worked on happen to be sprayers, commercial sprayers for golf courses, right?
Okay, right.
So the main thing that really is pushing this is California had come out with their AB 1346 law, their bill, that basically is pushing every piece of equipment sold after 2024, it has to, if it's 19 kilowatts or 25 horse and below, it has to have some sort of electric power source on it because they want to get rid of all internal combustion engines. So it seems to be the biggest driver that we see in the market. That's why I started working on this one anyway.
Yeah. So that's, are there other factors or compellers, if you will, in the market, or is it just the government regulation that's driving it? Or what else?
No, in this case, a lot of this equipment, if it's turf care, is, there's some pretty nice golf courses around the country, and a lot of that maintenance that needs to be done, either early in the morning or late at night. So they want to take care of their turf, so they don't want any oil spills if they don't need to. They want to keep things quiet. They want to keep some of that older, gas and diesel engines can smoke a little bit and they stink. And so people want things clean, quiet, and easy to maintain. So I think that's the other part of it, along with regulations.
So they're getting rid of the internal combustion engine and replacing it with some sort of electric power source, as you described. Is that a battery pack, or is that what is that? What's the electric source that seems to be the one that's being used most frequently now?
Well, right now, just because of needing that much power, up to, this first application that I've done, it was a 35 horse gas engine that we were replacing. The second one I did was a 25 horse unit. But yeah, mainly it's going to be a lithium ion battery pack. And, their lithium ion batteries have had a bad rap, when we first came out, because the battery manufacturers didn't do a very good job with, managing that power, right? So a lot of times they didn't have the proper protections, the proper monitoring of the batteries, and you end up having thermal runaway, and then that started fires, and
right,
it causes a lot of problems, damage to people and properties. So we on these projects, last 2, have coupled with Briggs and Stratton. out of Milwaukee, and they make a very nice product. They've been doing the turf care stuff longer than I've been into it, but they do have a real nice line of batteries. But the product that we're using on this application is their commercial grade Vanguard product, and they have it in a 5 kilowatt and a 10 kilowatt package.
Okay.
And they have all the contactors. They have CAN bus messaging, that we can talk to it with our controllers. They can talk to the inverters. So they do a good job of monitoring the cell voltages, temperatures, and just making sure that the batteries don't get stressed.
And is this the kind of unit where it charges overnight and then it goes all day? Or what's the recharge cycle on these things?
Well, yeah, that's the issue. Is it depends on the duty cycle of the machine, right? So when we did this first one, because the machine was to all hydraulic, we were able to put transducers and the recorder on, and we were able to get a duty cycle that allowed us to figure out what size battery pack do we need. So the first unit on our 35 horse unit, we chose 2 10 kilowatt battery packs. The customer said, well, we would really like to be able to run that thing for 4 hours if we can. And then we would like to be able to charge. They said maybe 8 hours, because the batteries themselves have what you call a C rating. The C rating of the battery, it says how much current can you pull out. And typically you can't charge as fast as you can pull out current out of the battery.
Right.
So they typically have like a 1/2 C or 3/4 C when you charge them back up. So yeah, goal is 4 hours operation, 6 to 8 hours of charge. When we did our first system, we only got about 2.5 hours operation, and it was taking us about 12 hours to charge.
Oh,
so
wow.
we fell a little short.
Well, it's still a work in progress in a lot of ways. I mean, I think that's one of the biggest challenges in a lot of mobile application spaces, not just turf care, is sizing that battery to the duty cycle as you described it. That's a real challenge. Yeah,
and that's such an important part, Eric, because I think when we talked about on your forum, a few of the other presenters were talking about cost of the batteries.
Yeah.
When I first started in it, it was, you could figure on the price of a kilowatt was going to be about $1,000 per kilowatt, right?
Yeah.
Then you start adding that up, it's like, holy moly, that's a lot of money, and it's going to really drive up the cost of our equipment. But since then, pricing has come down. I know they're automotive wise, they're probably in that $100 range per kilowatt.
Yeah.
We're as a fluid power and electrical distributor, we're still in that probably $400 to $500 range. So we're not quite there, but as the battery technology evolves, they're saying that's going to come down.
Yeah, I think we've seen that, and we'll continue to see it. It just becomes more and more of a need in the marketplace to find those lower cost solutions.
Exactly.
Yeah. Well, I'll tell you what, Dave, I do want to talk more about the actual hydraulic solution that goes on these applications that you described, but we've reached the point where I need to take just a quick break here because I want to make sure that I tell our listeners about IFBE, the International Fluid Power Exposition. IFBE is a very unique trade show. It's a place where you'll learn everything that you need to keep your company at the forefront of the mega trends that are affecting your business and your industry. From sensor technology and data analytics to robotics and automation, you will see at our show the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFBE can you have in-depth technical conversations with other engineers and other company executives to help spark new ideas. You can also talk to your suppliers about specific challenges and find new solutions that they may be offering. Or you can find new suppliers and new ways of doing things. Or you can attend innovative education classes and sessions that cover the latest fluid power topics and industry trends, some of which include college course material and provide professional development hour credit. No other trade show brings together as many sectors of the fluid power, power transmission, and motion control industries all together in one place. And this wonderful event happens only once every 3 years. in conjunction with ConExpo ConAg, the largest international gathering place for the construction industries. Our next IFB show is going to be held March 14 through 18 in 2023 in Las Vegas, Nevada. To learn more about the show and to reserve your place, visit ifpe.com. All right, Dave, let's get back into our conversation. And like, as I said before that break, we want to now start talking about the actual hydraulic solution. It sometimes gets lost in the discussion as these pieces of equipment electrify, quote unquote. In a lot of cases, we're only talking about replacing the power source with an electric power source. You're still using hydraulics or fluid power on the actuation of the device, right? So in this specific application, what is the hydraulics doing on this? You said it was a sprayer that you were working on?
Yeah. So they have this unit had, let's say it had 3 pumps on it. It had a hydrostatic pump for the propel, which ran off the 35 horse gas engine.
Right.
Behind it, a charge pump, and then behind that was an auxiliary pump that provided power for the power steering and also the raising and lowering the booms on the sprayer. So the customer wanted to keep the system pretty much intact, but they really were saying, hey, all we want to do is replace that gas engine.
Yeah.
So, but we're going, well, maybe there's a way to make this a little more efficient than just replacing the engine, right? So that was our first attempt. We sized up a Parker GVM motor to run the hydrostatic pump, charge pump, and gear pump. We said we're going to keep that the same, but we the product pump, which was a Hypro centrifugal pump to run the product spray pressure, that was done off of a belt and pulleys, right? Mm-hmm. So a lot of times this gas engine needed to be screaming at about 3,600 RPM to get the pulleys to spin that pump at the right speed. Plus, you see that a lot of times in skid steers too. A lot of operators will just ramp that engine up wide open, and then they use the hydrostat to do their fine feathering, metering, and stuff.
Oh, right. Mm-hmm. Right.
Yeah. So anyway, we decided to drive the product pump with its own GVM motor and inverter. So now we could individually separate those functions and make them much more efficient. So we still kept the hydrostatic drive because fluid power has a lot of power density, right?
Right.
So and you can put fluid power motors and cylinders in some really nasty environments. So the customer they spent a lot of money on roto molding these tanks, and the way they had it set, they couldn't put a solid axle across this with a differential that would fit underneath the tank. So that's why the 2 hydraulic motors, Parker wheel motors that were on the system, fit really nicely. Were small, compact, and you could distribute that power easily off the hydrostatic transmission.
Yeah.
So the original unit had a manual displacement on the pump, so we decided to go electronic, though.
Okay. So I'm sorry, Dave. Forgive the beginner's question here, but so you have 3 different pumps doing 3 different things on the sprayer. Did I hear that right?
Correct. Yeah.
And so do each one of those pumps have their own electric power source, or are they all coming off the same electric motor?
No. So that's why we ended up separating the units, so that we could go with it. We went with 2 separate GVM motors for this application. And once again, after down the road, after we seen the results of this, we even want to separate it even further yet. So, right. But you have to get into a situation where you got to weigh the cost of the extra motors and the extra inverters. The batteries stay the same, but you really do pick up a lot of efficiency by eliminating, especially the gear pumps in the system.
Yeah. So, I mean, a traditional, when you would have a hydraulic system that's working off an internal combustion engine, as you were just describing, you would kind of throttle the engine up as high as you could, or at the maximum level that you need to deliver the flow for the most intense application. And then you would use a valve block or whatever to thread that fluid to the right places. It sounds like that whole system has now been redesigned. Where do you still have valve-based actuation, or is it just the pumps that are delivering the flow for each actuated unit?
The only thing that uses the valve, it would be the booms.
Okay.
That functionality, we're looking at replacing those even, Eric, with electro-hydraulic actuators.
Right.
So there's EHAs, and so on our next machine, that's what we're going to do. We will eliminate, the gear pump running through the valve out to hydraulic cylinders, because those are pretty robust, and they're still using hydraulic, that compact, dense power to lift and lower those booms, but we're doing it electrically.
Right. Yeah. Well, I mean, I think that's one of the interesting and evolutionary parts of these marketplaces is, where do you keep using the hydraulics? It's primarily for the power density that you just described. I'm assuming that you're trying to move heavy things with precision, and currently hydraulics is still the best way to do that, right?
It is, and also, Eric, the other thing is once again, the sealing capabilities of hydraulics, the motors and pumps, can put them in a real caustic, dirty environment, and they live. Right. Electronics, on the other hand, you're paying a premium to get the IP69 rated, motors and electric actuators. So they come with a pretty expensive price tag on them too.
And they're much more delicate, as you're saying. They can't, don't shake them too hard, right?
Exactly. Yeah. So that hydraulics, I don't think are ever going to go away, but we need to, as an industry, make sure that we start, making the systems more efficient. And I think that comes by dividing the functionality up and trying to control them electronically as much as possible, but still use the muscle of hydraulics to do the work.
Yeah. And it sounds like even with the current solution that you're offering, you've seen efficiency gains. It sounds like. Can you quantify that at all? I mean, how much more efficient is it?
Well, let's take this for example. When we originally tested, I was telling you we've got about 2.5 hours of operation out of it, right?
Yeah.
Well, we were able to go and find the sweet spot of the pump, the hydrostatic pump lane that we used, and electronically control, that displacement, slow the electric motor down until it ran in its sweet spot. And we picked up 1 whole hour of operation out of that without changing anything but tuning.
Oh my gosh. Okay. That's like, did I do the math right? That's like almost a 50% increase. Right?
Exactly. Yeah, we still didn't meet the customer's target. They wanted 4 hours, and we got 3.5 out of it. So it's good. And we could do probably a little more tuning, but I think we can pick up the rest of that efficiency by getting rid of the gear pump that runs, that power steering and the booms. If we can get that parasitic loss out of there, and maybe go to a full electric, power steering system and some electro-hydraulic actuators on the booms, I think we'll pick that up, and we're going to get that 4 hours of operation that they're looking for.
Another big objective here, and I think that's what we led the podcast off with, is the idea of lowering the emissions, right? So one of the ways to do that is to get rid of that internal combustion engine. You're already eliminating, contaminating emissions to the atmosphere, if you will, as a result of doing that. But these efficiency gains themselves have an impact on that, don't they?
Well, they do. Yeah. I think from some of that earlier data that I put up on my presentation, an internal combustion engine, typically is only 30% efficient. So in the electric motor systems, if they're pure electric, we're probably talking about 97% efficient.
Yeah.
Unfortunately, you still have the battery chargers are somewhat inefficient, and we still have to produce the electricity. I mean, it just doesn't come out of the wall. There's still some emissions being created, but not at the vehicle itself.
Yeah, it's an interesting environment. I mean, you'd have to get like a PhD in actuary, I think, to figure out exactly where the net gains are. Because you have to, as you said, you got to produce the energy somehow, and that's either at a plant or on the job site. But the company or the person that owns the piece of equipment, the golf course owner, has a different perspective on that, right? So they're less concerned about the production of the electricity, and they're more concerned about what's happening on the golf course.
Exactly. And in this machine, these two sprayers, we decided to use 48-volt batteries
Yeah.
because we didn't, their mechanics aren't real high tech, high skilled mechanics that work on these.
Right.
And so they didn't want to have to send mechanics to seminars and schools to get actually qualified or certified to work on high voltage equipment,
Mm-hmm.
which you see in, your Teslas of the world and other EV machines that are cars and trucks that are on the road. But
Yeah.
with these systems, OSHA allows them to work on them without any special tools, without special rubber gloves and special training. So
Yeah.
it really fit nicely within with their particular servicing plans.
Yeah, that's even more important than ever. The machine operators sometimes don't have the training to fix everything. So that sounds great. So what didn't I ask you about that you'd like our listeners to know about this application?
Well, once again, the key thing I think is power distribution. You can get that power density where it's needed. We need to divide the functions up on a piece of equipment like this
Mm-hmm.
to try to only turn them on and use them when needed. So that really works towards evaluating the system first before you come up with a solution. Just don't throw everything at it, but try to listen to the customer, find out what their demands are, their reasons for actually doing a project like this, and then coming up with good, solid engineered solutions to give them everything they're asking for.
Yep.
Try to meet all those requirements.
Is that where you see this technology going? Things are going to get smaller and more compact and be able to turn on and off, or are there other? I mean, what do you think the next generation of these machines are going to look like?
I think so. It's I'm currently doing another project here that's an 85 horse. It's a mulcher, and so we can't perform. We can't find a motor or get Parker to size us a motor that runs off of 48 volts. So you typically, once you get over 45 horsepower, you're going to be pushed into a higher voltage application.
Mm-hmm.
So what we're doing on now with a 350 volt battery system on a mulcher, and so you have to be real concerned about. Now it's high voltage. You have to be concerned about vibration, thermal management of that whole system, and so it's just another realm. But once again, I'm seeing, and I really like working on these applications that are, say, that 40 horsepower and below, because I see the battery electric hydraulic systems work real well in that realm.
Yeah.
So there's a lot of equipment out there. I had somewhere I did data gathering, and it looked like in California alone, there's 16.7 million small engines in California that are running today, right?
Yeah.
1.5 million of them are commercial applications. And that's exactly where our customer is trying to sell to, is that type of market.
That's a lot of hybrid hydraulic solutions coming to market pretty soon.
Exactly.
It's all moving that direction.
It's going to go up. We're talking about only the 19 kilowatt and below.
Yeah.
I think that there's going to be some more government regulations that are going to start pushing that up into that, the 45 horsepower stuff and 50. And with that, and, especially in California, there's so much fruit processing out there that, a lot of that equipment is sized right in that same area.
Yeah. It's always important to find the opportunities in the marketplace, and it sounds like you and Nott Company are doing a good job doing exactly that.
Yeah, that was one of Marcus's goals, is to try to keep pushing to keep Nott Company being a chameleon and being able to change with the times.
Right.
So that's what we're doing.
All right. Well, great. That's going to take us to the end of our time together, Dave. Thanks so much for being on our show. And
well, thank you for inviting me, and it's fun to talk to people in the fluid power industry that that are thinking the same way. That you aren't going to replace fluid power. Fluid power is going to be viable for a long time, but it's just how we're applying it is going to make all the difference in the world.
That's right. Well said. And that is going to wrap things up for this episode of Fluid Power Forum. So my thanks again to Dave Heiling, who's been my guest on this episode. If you'd like to contact him, connect with him, learn more about these applications and what they might be able to do, the best way to do that is by his email address, and we'll put a link to that email in the show notes for this episode. I know he'd welcome any additional reach outs on this information. Remember, if you like our podcast, follow us on Twitter. We're there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We're truly interested in hearing from our listeners about the kind of topics and fluid power systems you'd like to learn more about on our podcast. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and I want you to join us next time in the forum.